Hello guys, so we are going to continue the discussion with respect to statistics. In this video, we are going to discuss about Pareto distribution. Now already in our previous video, we have discussed about power law distribution. Power law distribution is nothing but it specifically follows this 80-20% rule. So any distribution that follows this power law is basically specifically called as Pareto distribution, right? And this is a non-Gaussian distribution, right? It is a non-Gaussian distribution, and obviously we have seen a lot of examples with respect to power law. But mathematically, right, we really need to understand something very important about the Pareto distribution. Okay, so usually in this particular scenario, if I probably consider an example, so this can be a Pareto distribution. This shape can be basically a Pareto distribution. You can actually change this height also. This height can also be changing like this, right? It can also be something like this, right? But mathematically, you really need to understand one very important thing about the Pareto distribution. If I probably discuss with respect to probability density function. So here you have this alpha value, right? Now as the alpha value, so alpha is a value with respect to the probability density function, right? Whatever, as soon as you will probably be seeing that as the alpha value will keep on increasing, this line you'll be seeing that it will keep on increasing, and finally you see that it is meeting to this particular line where it has this value as 1. Okay, so always remember, in types of Pareto distribution, it is specifically defined by this specific hyperparameter, that is alpha. And as the alpha value keeps on increasing, right, when it goes and it keeps on increasing, here you will be seeing the height of this particular probability density function will keep on also increasing. But at the end of the day, you'll be able to see that it will be reaching this line of 1, right, with respect to any random variable that is x that is present over here. Now one important thing about Pareto distribution you need to understand, like let's see, like if we have a log normal distribution, right, which looks something like this, right? This is a log normal distribution. If we add log normalization, if we probably apply a log normalization transformation onto this, then we specifically get a Gaussian distribution, right? Gaussian distribution. So here you can see that this specifically log normalization that I'm specifically applying, it is basically called as transformation technique, right? It is a transformation technique. Now similarly, if we have a Pareto distribution, let's say if we have a Pareto distribution, can we convert this Pareto distribution by any transformation technique into a Gaussian normal distribution? Yes. And why do we do this? Because in most of the machine learning algorithms, we specifically use Gaussian distributed data because it will be able to increase the performance of a specific model. There are some assumptions for some of the machine learning algorithms, which we'll be learning in the future. And through that, you'll be seeing that how we can probably convert a Pareto distribution into a normal distribution, right? So here, the technique that is specifically applied is something called as Box-Cox transformation. Okay. Now, what is the formula of Box-Cox transformation? Right now, don't worry about it, because with the help of Python, I'll definitely show you that how you can probably do the Box-Cox transformation. But just understand, this is a transformation technique which will probably convert Pareto distribution into a normal distribution. Okay, now let's go ahead and discuss about some of the examples and understand Pareto distribution has a lot of advantages. It is used in various domains, specifically in IT industry, right? If I probably consider, I can give you two amazing examples. One saying that 80% of the entire project, okay, is done majorly by the 20% of the team, right? So you'll be seeing this in a specific IT company, right? The 20% of the team members, right, will specifically be doing more than 80% of the work, right? So always, specifically working in IT companies, we are overloaded, right? Now, if I probably go and show you the second example, right, 80% of the defects can be solved if we solve 20% of majority of the defects, 20% of defects. So let's say there are 20% of main defects that may lead to the rise of the 80% of the defects, right? So if we are able to solve this 20% of the defects, remaining 80% can be easily solved, right? And similarly, there are different examples, right? Different examples in IT industry, in the normal things. You can probably say that 20% of the entire people actually hold 80% of the weight. So this can also be there, right? You can also consider with respect to salaries, right? Like 80% of the companies that are probably giving the salary to the individuals, right? They are nothing but 20% of the entire individuals present in that specific company, right? So majority of the salary. So this all kind of examples are with respect to Pareto distribution. One important thing that you should always know, Pareto distribution always follow a power law distribution, right? Power law distribution, right?